And just to put everybody on the same page, I put a summary together for my guys out in California about whom you guys are and what type of work you do. And I laid out the summary of using the RKI GX-2012 with the 5 sensor capacity. One of the things that I wanted to emphasize and I shared with my guys to go over was the ability to measure occupational safety, which we refer to as percent lower explosive limit. That's the unit of measure that we use to keep our employees safe. And then the next step is to working into application-specific fields where we're working with 100% by volume gas. This is something that Bob and I have talked to quite a bit, and understanding a traditional lower explosive limit sensor that we use for occupational safety cannot live and will fail very shortly after if you continually expose it to 100% by volume gas. And this is the world that the GX-2012 lives in, and this is the world that we use it for normally on transmission gas pipelines, you know, anywhere from 6-inch pipelines all the way up to 32-inch pipelines. But we find ourselves also within applications of application process controls where people are blowing down lines that generally have hydrocarbon in them, and we need a way to safely recognize when we can get into them and do work on them, cut them in, change pipe, move pipe. And I believe that's really the application that you guys at Carl are looking at mostly, is from a safety perspective, making sure that those lines are blown down and there's oxygen in them and no hydrocarbon. Am I on the right track with that?
Yeah, we're not talking about changing. We're actually taking, you know, with torches, cutting holes in it, welding on them, you know, on an open system.
Perfect.
Not hot tapping. This is, you know, penetration through the pipe and making welds.
Perfect. So we're going to be monitoring in and around the area after the fact and before the fact to make sure that there is no hydrocarbon in any unit of measure above the parameters which you require. Now, for instance, in our applications, when we deal with the large pipeline transmission, they don't get into those lines until they're below 10% LEL. But they're cutting into them, and we measure those vapors all the way through percent LEL into percent by volume. So we know when the line is blown down appropriately, and they know when the line is filled up appropriately with no oxygen in it and only a percent by volume gas. So we're going to give you.
When you say cutting into them, is this a cold cut or a torch cut?
They torch cut them.
Okay.
Yeah, they'll start off on those pipelines and they'll get after it. It's a pretty interesting technique that they use. They actually pack mud around their welds as they go. In any case, I know that all applications are a little different, and I'm not an expert in all of them. So what we'll do is we'll describe the technology, and we'll describe to you how it works. And then with your knowledge of your applications, of how you do things, we'll try to find a point where they come together, where you, with high confidence, know that you can use our tool to measure the atmosphere the way that you need it to work. That sound about right?
Yep.
All righty. Hey, Rainier?
Yeah.
I do not have a picture on my screen as of yet. All I'm seeing is the Pro-Am/GX-2012 webinar on a black
That's all
white.
we have.
I'm going to turn it on right now.
Okay, great. Hey, Zach and Bob, are there any questions that you guys have specifically before we show you the GX-2012? We're going to show it to you in its normal operation as a 4-gas compliance tool. And then we're going to talk about us having the ability to put a 5th sensor in the unit, which allows us to auto range. I know this is a new term, but we're going to allow the instrument to move from a percent LEL measurement into a percent by volume measurement with your employees never having to touch the unit.
No, I think we're good as far as that. I will say this, after we go through this, there's a couple scenarios that have been discussed around the room. that they've gotten themselves into recently. So I want, if it's okay with these guys, to throw these scenarios out to you,
Sure.
and that way you can, probably explain how this meter would have affected that situation.
Yeah, we
Okay.
can try to field those. Sure.
I missed that. I couldn't hear what was said.
Yeah, basically, he was stating that they've got some field scenarios and situations that they would like to see how our unit might respond in. And after we go through the presentation, we'll get presented those questions and see if we can field some answers to them.
Yep,
Okay.
that'll work.
Okay.
Well, that's wonderful, because the guy you're looking at, John Villalobos, he's my go-to guy. So understanding how the technology works and how we can use it with your application would be a great opportunity for us to learn as well. So with that, John, you want to take the floor?
Sure. Yeah, thanks, guys. Yeah, so I'm John Villalobos, or John V. Actually, if you're looking for me here at RKI, just ask for John. I'm the only John here at the home office. Basically, I'm one of the application engineers here, so my primary support function is to assist our distributors and end users in their gas detection needs and questions that they may have. Basically, today we're going to cover the GX-2012, as you know, and actually we do have this unit set up with a 5-sensor configuration, so we will cover the standard 4-gas configuration of it, and we'll look at the percent by volume thermal conductivity sensor that John was talking about. And so we'll get started with that. I'll show you the display of the unit. We'll talk a little bit about the technology of the sensors. And before I show you the unit, the face of the unit, I wanted to ask how many total sensors would there be prospectively in your guys' units? Of course, LEL for combustibles, the percent by volume sensor, and beyond those two, what other sensors might be on your units?
The oxygen.
Okay. All right. So no need for hydrogen.
So what the meter that I got sent from you guys here, and I have it right in front of me,
okay,
has all 5.
I see.
Okay.
All right.
Now, whether or not they choose to continue with the other 2
right.
or 3, that's up to them.
Okay. And
this is configured with all 5.
Right. And I can touch briefly upon that as well to see if you guys think it's appropriate or not. Okay. So what I'm going to do next is I'm going to come around the table behind the camera and hold the unit up to the camera and see if we can get a good display.
What do you guys want to do with them, or?
Okay. Okay, so here we've got the display of the unit, and this is the standard 4-gas configuration that we're looking at, obviously. And it's really typically what you would see, even if you had 5 sensors in your unit, which I do, as well as you there in front of you, you mentioned. So what we see on the display is methane, CH4, oxygen O2, CO, carbon monoxide, H2S, hydrogen sulfide. So for the standard LEL range, the low explosive limit, it's basically methane in this case. We are looking at a 0 to 100% LEL range. So basically your scale is broken up into 100 units from 1% LEL, 2% LEL, all the way up to 100% LEL. And the lower explosive limit to the LEL for methane is 5% by volume of methane, okay? So basically that 100% LEL range is equal to 5% by volume for methane. So if you have a thermal conductivity sensor for the high range, basically that is an auto-ranging function in this unit, as John Maslowski mentioned. And basically you would see the display go from 0 up to 100% LEL. Once 100% LEL is exceeded, then the designation, the units will switch from LEL to percent vol, is what you would see on the display, and continue on up, theoretically up to pure gas, 100% volume, if you had that much gas present. Okay, so you do have a huge capacity for measuring the concentration of the gas. Touching upon those concepts, The technologies that we use are what we call a catalytic combustion sensor or a hot wire sensor. It's almost, if you can liken it to almost like a light bulb in a sense that there's two filaments or two beads inside these sensors. Conceptually, you have a reference bead and an active bead or element. Basically, the reference is your baseline measurement. The active element basically measures the gas itself. So the active element has what we call a catalyst coating on it, and that's why we call it a catalytic sensor. And the purpose of that catalytic coating is to enable us to measure the gas at below LEL levels, because without that catalytic coating, you would measure the gas right at the LEL, because that's when gas will become combustible or flammable, when you have the right mixture of fuel to heat and oxygen all together. So to safely measure the LEL, we have to put a catalyst there to enable that measurement at way below the explosive or flammable levels. In this case, you'd be able to see readings at 1%, 2% LEL, so quite a bit below, obviously 100% LEL, and that's the purpose of the catalytic coating. So in the presence of frequent gas exposures or high concentrations of gas, then what happens is that catalytic coating oxidizes away and the sensor becomes desensitized over time. So what we need to do is we need to save that sensor and prolong its life as much as possible. And basically, if you have a lot of gas present and you have that fifth sensor on board, if you had a 4-gas standard unit, or let's just say the percent by volume sensor as well as that catalytic LEL sensor, then it automatically switches over. And when it switches over, the catalytic sensor shuts off and basically saves it from getting burnt out, so to speak, too quickly. And then you're looking at those high measurements on your percent by volume sensor, which we call a thermal conductivity sensor. That sensor is similar to the LEL. It does have a couple of elements as well, a reference and an active. But in this case, there's no catalytic coating on that active element. Basically, we have the reference isolated from the active so that when the gas comes in through the unit and to the sensors, it actually cools down that active element in comparison to the reference element. So we apply a voltage to these sensors, whether it's the catalytic or the thermal conductivity. We apply a voltage and current to these sensors. We heat them up to a certain temperature. So in the case of the catalytic, the active reference is heating up compared to the reference element. And for the thermal conductivity, the active element is cooling down compared to the reference. So that thermal conductivity sensor is cooling down, that gas is cooling down. That's how we measure it. But as a result of that, just cooling it, we don't have a catalytic coating on it. So therefore, it's not going to prematurely have a short life with a lot of exposure to gas. It doesn't need oxygen to operate, whereas the catalytic does. Since we are oxidizing the gas those heated elements, we actually are using, and we need oxygen to get a reading. We need about 8 to 10% volume of oxygen to get an accurate reading on that catalytic sensor. So basically, those are the technologies as they apply to these sensors. And one important point is if you are in an application where you expect to see a lot of gas, possibly right off the bat, then you would probably be well served to put the instrument into percent by volume only, turn off that catalytic sensor right away, therefore saving even more of its life. Because again, when it sees a lot of gas, that LEL sensor is going to range up to 100% LEL before it turns off. So you are taking it up to full scale before it turns off anyway. And if you anticipate a lot of gas, put it in percent by volume, activate that TC sensor, turn off the catalytic initially, and you'll even save even more life for it. And I'll show you how to do that as well. Okay. In addition to those two sensors and technologies, we have what we call a galvanic sensor, or basically an electrochemical sensor for the oxygen. And that range is 0 to 40% by volume. Normal oxygen content at sea level is 20.9%. And then we also have, in this case, the CO sensor next, and the hydrogen sulfide sensors, which are electrochemical sensors as well. If you have combustion taking place, anything like that, then you would have need of a CO sensor. If there is no combustion taking place in your applications, then you probably don't need the CO sensor, as long as it's not a byproduct of whatever is going on in your application. Hydrogen sulfide, H2S, the rotten egg odor, that is very distinctive to identify that gas. Basically, anytime you have organic matter decomposing in sewage systems, in the ground, oil fields, pipelines, if you think there's any organic matter that can decompose in your application, then you may need an H2S sensor, hydrogen sulfide. But again, that rotten egg odor, your nose is very sensitive to it at a very low level, so you're likely to detect it quickly. You'll know if it's there. Just you'll smell it. Okay, in short. All right. So here we are at the normal display, and what we're looking at is again those 4 sensors that I mentioned, and we have some buttons here. We have the power enter button. We have our air button to air adjust the unit. That's one of the things we want to do whenever we turn the unit on before we use it. We have a shift down button. Then we have a display button and then a reset button. So anytime you get an alarm condition, you can start to quiet those alarms down once the gases come down by pressing that reset button. And it also silences the audible. Okay? So the first thing I want to do is air adjust it. So we'll do that first. So let's say you turn the unit on. It's gone through its diagnostics. This is what you're going to see. Then it's going to come to this screen. All right, then I'm going to press and hold the air button. It says hold air, adjust, release. I'll release that, going through a little bit of a countdown. And then finally 0, and then we're back to our normal screen. If I had failed an air adjustment, we would get a fail indication at this point, and it would indicate which sensor failed to 0. So basically, the unit is zeroing the methane or your LEL sensor. The TC sensor is getting zeroed. The CO sensor is getting zeroed, and the H2S sensor is getting zeroed. And it's bringing or air adjusting the oxygen to 20.9%, which is its normal reading. And again, this is an auto-ranging unit, so you'll never see that 5th sensor on board as a 5th line item on the display. That LEL line item, the CH4, again, that auto-ranges appropriately from %LEL, 2% by vol. So you're always only going to see 4 gases or 4 sensors on the display at any time. Okay, just to clarify that one more time. All right. So one of the things that you can do, as I mentioned before, is to go into % by volume only, or select that. And you do that by pressing this display button. The display button gives you several things that you can do. And if we press this display button first, with the initial, it says HC hydrocarbons select HC range. Okay, if I press enter right here, right now it's at auto ranging. So that's the normal setting for a 5 sensor configured unit, or at least a LEL and % by volume configured unit. And if I press my up and down arrow keys, I can make that only vol. So that's what you would want to do and lock that in. Okay, end. Okay, and so HC select, and there's other things in this display range as well. I can go to peak readings, the short-term exposure limit, this is for toxicity levels, time-weighted average, over 8 hours. You have your alarm points can be displayed at startup, time and operation, the date and time, log time, data logging. These units are always data logging. It's up to you whether you want to use that function or not. And they overwrite the oldest information once they get full. Okay. Clear the log. You can clear the data logger if you want. User ID select for data logging purposes. Station ID select, again, for data logging purposes, identifying stations as well as personnel. And then display, this is snap logging or quick data logging display. And we have a bar hole select capability if you want that activated or not. And then finally back to the normal operation mode. So basically,
for our purpose, why would you want to just immediately from the get-go take out the auto range and put the volume percentage?
Okay, only if you think you're going to hit this thing with a big slug of gas. If you're pretty sure that's going to happen, then you could take out the LEL range and just see how much gas is there, and by going into the volume range only. So, but if you're not sure and you're really concerned with safety first, you can just leave it in the auto ranging, the normal default.
It's going to automatically switch back to If you just leave it as a default rather than, you know what I mean?
Well, right now, see, I went back into it and it still says only vol right now. I haven't turned off the unit. I would expect it to stay in only vol, although I'm not positive. We can test that a little bit later. I'm going to go back to auto ranging right now. Okay. Or we can look at it right now if you want. Let's since we're talking about it, let's do it now. Okay, I've selected only vol. All right, and I'm going to lock that in. And I'm back to HC select. If I don't do anything at all because I'm in this display function, it will time out and go back to the normal screen of LEL, O2, H2S, and CO. But let me turn the unit off. Okay, I've turned it off. Now we're going to turn it back on. Okay, so you can see all of the segments possible come up initially. It gives you the next cal 90 days. I just calibrated a few minutes ago. That's our default settings every 90 days. You can adjust that if you want. It's going through a battery life, alarm points, full scale ranges. That's what it's going through right now. Okay, so now we're at the normal display mode. All right, so let's go into that setting one more time. Press the display button. HC select enter. Okay, so it went back to auto ranging. Even though I selected it to percent by vol, once I turned it off and turned it back on, it did default back to auto ranging. Okay, so now we know. All right, so I'm going to leave it there. We'll select that.
I was just curious.
Yeah.
I was just curious.
Well, it's a safe default for sure because obviously worker protection should be for LEL initially, and so I think it's appropriate to have a default doing that. All right.
Can you click on the screen whether it's reading by percent?
Yeah.
Okay. So now I just let it sit there just to show you if I don't do anything else once I'm in this display function. If I'm at any one of the selections in this display function and don't press that button for maybe 10 seconds or so, it's going to default back to your normal screen here. Okay.
So if you're in the say you are in the volume range.
Yep.
And you take it out of the default and you make it volume. If there is 1% of LEL in the air, what would that reading be?
That would be very low. It would be point something because 1% by volume is 10,000 ppm basically. So again, 5% by volume is 100% LEL, right? So it's going to be, yeah. So you would definitely want to be in the LEL range. So 50%.
1% in volume is what?
10,000 parts per million, basically. So for methane, for example, 50% LEL is what we use a cal gas to calibrate these to. That would be 2.5% by volume is 50% LEL. Okay. All right. So now let's look at a calibration then. So I'm going to put this on the table, and we'll adjust our camera.
I'm really confused on the LEL sensor. You were saying something about new knobs.
That's our MFA.
If we're required to put a nitrogen plant.
No, I'm gonna have him talk about it again. I want him to explain further on our application of what we're doing when we're purging, how his sensor
Hey guys,
works.
I think it's also nice to recognize that our LEL and thermoconductivities are independent of each other.
Yes.
As is our oxygen sensor. So when we do begin to show at higher volumes of gas, percent by volume gas, we will be decreasing the levels of oxygen. And we will read all the way down to 0% oxygen in environments.
Right.
Independently of all the LEL or thermoconductivity sensors.
Right. Right. So, and of course, so that would be a good indication that that oxygen is getting displaced by something. So, yeah, if you're inerting something, then you can see how well that inerting process is going by a combination of lowering of the LEL sensor up to 100% LEL. It's going to get lowered pretty quick. Then this 60% by volume.
So, yeah, so when you guys do purge your lines with nitrogen, you're going to see the oxygen level go from 20.9 down to 0.
Right.
And that will be an independent measurement of any hydrocarbon that may be present.
Right.
So when I work with our transmission pipeline guys, they almost use the two sensors as independent verification that what they believe is happening in the pipeline is happening in the pipeline.
Right. Yeah. So we strongly recommend the O2 sensor be present along on board with the LEL and Catalytic for that verification purpose, as John's talking about. Okay, so we'll do a calibration next. I've got a 4-gas mixed cylinder here, 50% LEL methane, which I mentioned is 2.5% by volume. Then I've also got 12% of oxygen, 50 ppm of carbon monoxide, 25 ppm of hydrogen sulfide. The balance is nitrogen. Okay, so what I'm going to do next is get into the Calla Mode, which is going to be press this shift down button and the display. Okay, the first thing that comes up is air cal. So I'm going to do an air cal to show you that function. Okay, so I'm going to press the enter button to select that. And right now I'm being directed to push the air key. And I'm going to hold that air key, ADJ adjusting, release. Okay, I'll release it. It's going through a countdown. We did this before we got into anything else earlier. So it's kind of a repeat of that function, but I just want to show you it because you can air cal it in the calibration mode as well as air adjust it in the normal operation mode. So you have two places where you can make that air adjustment. Okay, the next thing I want to do is go down to auto cal, and basically we're going to calibrate all 4 sensors at once, and then we'll calibrate that thermal conductivity sensor afterward. Okay, so I've already got my regulator and tubing hooked up to the cylinder, and I'm going to press the enter button here. And right now, I've got my values that the unit expects to see, which these values do match the cylinder, so that's good. All right, and just want to continue with that. So I'm going to press the power. Once the values are valid and verified, press the enter button, and right now it says auto cal is flashing. With all of our units, something on the display has to be flashing when you put the gas to it. And they're all a little bit different, but if the values aren't flashing or you don't have a message flashing, it's not ready to receive gas. So I'm going to go ahead and put the gas to it now. Okay.
I am snowing.
All right, so we're going to let those readings climb up and stabilize. Our operator's manuals say to flow the gas for 2 minutes, but in reality, you really don't have to go that long. If they stabilize sooner than that, then that's sufficient. Okay, they're pretty quick. You can see how quickly they responded. So we're already at 50% LEL on the methane, 12.2% on the oxygen, 49 ppm on the CO, 24.5 ppm on the H2O. So we're really close, which we should be because I just calibrated this earlier before we started the webinar here. Okay, so we're just going to flow that gas a bit longer, and the readings may go up and down just by a value. Okay, so it's pretty good there, fluctuating up and down. Okay, so that's fine. So at this point, I'm going to press the power button, pass, take the gas off. Okay, and then it's back at auto cal. I'm going to go back into auto cal again. Okay, and this time I'm going to press the down button, and that brings up my percent by volume. It does say vol percent next to that 50, methane 50 there. Okay, then I will get my other cylinder ready here, and I'll press the enter button again, because 50% by volume is what my cylinder says. It's got 50% by volume. You may have 100% by volume. We also sell those cylinder gases. And so that auto cal value might be set to either 50 or 100. Excuse me.
Hey, John.
Yep.
I also sent 100% by volume gas over to Bob, and we also did a calibration in the 1-cal rather than the auto cal, which does not require the value, the auto cal value at 50 that you said.
Right, because in the 1-cal mode, yeah. You can adjust it manually.
Yep. So Bob, when I calibrated your instrument with you yesterday, we did it in the individual cal. not the
Yeah.
auto cal mode. So there's a little bit difference than what we had talked of.
Okay.
Okay, so I'm flowing the gas here. I don't want to waste gas, so I'm stabilized. I'm gonna press enter. Okay, pass, remove that. Okay. And we're back to AutoCal. So now we're done calibrating. So if I do my up and down arrow key, I can go to 1Cal, and there's other functions in here, normal operation, back to normal operation. Did you want to cover that 1Cal, John?
No, I don't think we
Okay.
need to.
Okay.
But just
the 1Cal does each sensor individually, and instead of an AutoCal value that the unit expects to see, you actually use your up and down arrow buttons to make your value match the cylinder. And then once it's matched, then you lock it in with the power enter button.
Yeah. Okay. One thing I do want to touch on, or John, if you want to get back to normal operation,
yeah,
I want to add a little note here.
All right, let me get back to normal. There's normal on the screen. Press power enter button. Now we're back to normal. Okay.
Okay. Real quick, what I wanted to point out is this: on any unit, and for that matter, any manufacturer's unit that has a pump, it's very important that we allow for the pump to pull the sample from the cylinder. And I say that because the pump itself has small little diaphragms in it, and it's going to lead to that pump pulling the sample from the calibration cylinder. It's going to add to the life of your pump if you do use a demand flow regulator. What we have seen and what you will see, if you use a traditional regulator that you turn the valve on and off and you allow gas to escape, those regulators can have different liters per minute flow. We generally will pull a sample at about a half a liter when we use our pump. Now you may say, well, hey, I have a regulator that I can turn the valve on and allow for the gas to flow through it. Yes, you can do that, but it's not suggested because you're going to be pushing air through the pump rather than letting the pump pull it. It's going to do a little bit of damage to the pump, and over a long time, you're going to see it being negative. The other aspect is if you're not sure what the flow is of that regulator, you will not get an accurate calibration. Bob and I were doing some calibrations the other day, and we took a look at what happens when you put a regulator that is 1 liter regulator or even more, and it causes the sensors not to read correctly, which will in turn not calibrate the instrument correctly.
Right.
So when you guys are looking at calibration, make sure that you supply your guys with the correct tools. Bob, I'm going to always suggest that you use a demand flow regulator to do this. So we allow the function of the pump to do that for the calibration process. It's just a good note to point out because many people will not do that, and they'll use a fixed flow regulator on a unit that has a pump. It just leads to problems, and we want to avoid that.
Good point, John. The other thing I want to touch upon, just when you get the unit, it comes in a box like this. It's got some part numbers on it and other identifications, serial number as well. And you also get a check sheet, which basically covers the gases, the ranges, low alarm, high alarm set points, and the calibration as well. And then you also have a 10-foot hose here with a quick connect fitting. Female goes onto the male inlet fitting, and then we have a threaded fitting on the other end, which goes basically you screw on the probe tip to that. Okay, so there's your hose and probe assembly. We also sell different lengths of hoses and probes, up to 100 feet if necessary, if you have to sample from a place which requires that much length. You can also have a rubberized little nipple here, which just fits on the inlet fitting like so. You can go around sniffing flanges, joints, etc. Using that. And it also comes with a small lanyard, wrist lanyard that you can attach to the unit.
Hey, John, I want to also add this, if you could. I would like you to apply the calibration gas, the 4-gas calibration standard to the unit.
Sure.
I want to show them how it will react. And I'd like to set the unit into its alarm state.
Okay.
I would like you to show them the function as to how you can silence those alarms so they can understand when they're working with it, they can silence the alarms, but yet still know they're in a potentially hazardous environment.
Okay.
I
So
would like
okay,
them
John.
to have you. Yep.
John,
yes.
Yeah.
you don't have to do that. I already did that for him.
Oh, you did?
Okay. Did you also show them the percent by volume?
No, I haven't got that far yet. I was waiting for you.
Okay.
All right. Hey, John, just
we'll
do
do
the
that
percent
next.
by volume.
All right.
Show them how it auto ranges.
Okay. So we'll do that next. Let's see if we can zoom in closer on the CH4 methane channel there. So I got my percent by vol cylinder ready. Okay, just making camera adjustments, guys. So you want me to tilt it up? Okay, can you guys see the actual LEL on that? That's kind of fuzzy on our screen. Okay. So yeah, obviously 0% LEL. I'm going to put the percent by volume gas to it.
If you could silence the alarm, John, that'd be great.
There we go.
And you'll see, guys, that it went from LEL up to 50.
Yeah. So now it's dropping 20.7. So oxygen is almost to 20.9. So you can see that we're down to 1% LEL. It may take several minutes to go back. In this case, it didn't. It went back pretty quick. But sometimes it'll take a while. If I had the gas there longer, it would have taken longer to clear out. Ultimately, back down to 0. You'll get quick clearing out down to about 1 or 2%, and then it'll hang around there for just a little bit longer before it goes to 0. But you notice we're still alarm condition here, even though we're back at normal displays because the alarms are latching. That's the default. And so that way, it's a safe way. That way, somebody's got to acknowledge that the unit is in alarm condition. So if I just press the reset button now again, it clears the visuals out as well. So
what we did.
Yeah, go ahead, John.
I was going to say what we did, guys, is, for instance, if we walked up to a pipe that was full of percent by volume gas, you'll see how fast it will react if you put the nozzle of the instrument close to it. And it's nice to see that because normally it's not going to happen that way. You will be moving towards an area or location normally in an occupational health and safety mode. We're worried about the person. And you'll see that unit climb up through the LEL slowly, like you're walking into a cloud of gas. And then as you're made aware of it, you're going to know that you're going to be looking for a higher concentration. And that's from the percent by volume, or that's the application that you're using it in. You could make that choice by using that display key function to say, hey guys, I know that I'm going to be working in high concentrations of gas. I would like to keep or prevent my LEL catalytic bead sensor from burning hot. And when you do that, you preserve it because you're not going to be burning the catalyst off of it.
Right.
So oftentimes when I speak to people about my equipment, I'll often hear what happens to their equipment presently, and that is, hey, John, we keep going through a lot of LEL sensors. I don't understand why. Well, the reason is they keep exposing those LEL sensors to high concentrations of percent by volume gas, and they're just burning the catalyst off very quickly. So by introducing auto ranging and the ability to turn on and off that LEL sensor, we're giving you guys a chance to recognize these applications and save those sensors so you're not using them as fast as, say, a company that doesn't offer auto ranging or the ability to turn it on and off. So is that a big deal? On a sales perspective with guys that don't really want to learn how to push buttons, no, because those guys are just going to turn the unit on, they're going to go to work, it's going to do its job. But when you look at cost of ownership issues, and we can show you how to preserve the sensors when you know you're going into the applications, it's a great deal. because when you look at $120 to replace an LEL sensor, those dollars add up. So if you know what you're going into and we can preserve that sensor for you, it'll make a monetary impact on your cost of ownership. The other aspect of it is just training you guys on the difference between LEL gas and percent by volume. Now, our distributors are all technically trained to do that for you. And, you know, the hopes are is that they're learning about your applications and how the tools best fit your application. And that's how they choose the RKI brand over perhaps somebody that doesn't have the knowledge base that will sell you a 4-gas instrument with an LEL sensor, but not know what the percent by volume gas will do to it. So these are all little things that add up in the end. But I'm confident that this is probably the issue you've seen with the quickness that your old LEL sensors were burning out. They just weren't paying attention to how fast the catalyst was being burned.
Right.